Hi class, today I'm going to show you guys how to solve the equation 8x squared plus 6x minus 70 equals -5 by using three different methods. So there are three different ways that we can solve quadratic equations. We can do it by factoring, quadratic formula, or completing the square now. It doesn't matter what way we do it, but we should get the same answer at the end. Let's start with factoring. If I'm going to solve this equation by factoring, I need to set it equal to 0, meaning I need to add 5 on both sides, which is going to have me rewrite the equation as 8x squared plus 6x minus 65 is equal to 0. I usually want to, if I'm going to factor, I'm going to want to look for a GCF. I see 8, 6, and 65. There's nothing they have in common, so there's no GCF. We're going to go straight to factoring by grouping. I'm going to multiply the first and last term. 8x times -65 would give me -520 x squared. And then on the bottom, I'm going to put the middle term, which is 6x. So my goal is to try to figure out what multiplies to -520 x squared and adds up to 6x. So that might take a while to do because this is a large number. But what does work is -20x and 26x. Knowing that, that's going to allow me to rewrite this equation as 8x squared minus 20x plus 26x minus 65 equals 0. Now I'm going to factor it by grouping. I'm going to look at the first two terms. And I see 8 and 20, so we can definitely factor out 4. They also both have x, so we can factor out x. Inside, we have 2x minus 5. For the other two, I see 26 and 65. I can factor out a 13, leaving me with, again, 2x minus 5. And then from here, that tells me one of my factors is 2x minus 5, and the other factor is 4x plus 13. Now that we have our factors, we can use zero product property and set each factor equal to 0 and solve for x. For the first factor, we have 5 over 2. For the second factor, we are going to have -13 over 4. So that was the factoring method. What if we want to do it via quadratic formula? Will we get the same answer? Let's see. So in this case, similar to with factoring, I have to set it equal to 0 first. So I'm going to add 5 on both sides again, and I'm still going to get the same thing I started with factoring. But if I'm going to use the quadratic formula, I need to identify A, B, and C, and then plug that into the quadratic formula. A is 8, B is 6, and C is -65. So plugging that into the quadratic formula will give me x equals -6 plus or minus square root of 6 squared minus 4 times 8 times -65 all over 2 times 8. Simplifying the square root, or what's inside the square root, 6 squared minus 4 times 8 times -65 is going to give me 2,116. 2 times 8 is 16. Simplifying this a little further, if we put square root of 2,116 in your calculator, that actually works out really nicely. That's 46. And then from here, we're just going to break it up into the two expressions as -6 plus 46 over 16 and -6 minus 46 over 16. -6 plus 46 will give me 40 over 16. And then over here, we'll have negative 52 over 16. We're going to need to reduce each of those fractions. 40 over 16, each of those divide by 8, so that this becomes 5 over 2. So that's one of my solutions. The other one, 52 and 16, both divide by 4, which will leave me with negative 13 over 4. And notice what we do have here matches the answers we got using factoring. So we're getting the same answers, but we're doing the work in a very different way. So we've done factoring, we've done quadratic formula. The last one is completing the square. With completing the square, the thing that's different about starting out in comparison to factoring and quadratic formula is it doesn't have to equal 0. The thing that's different here is what we want to isolate are the variable terms. So we're not going to add 5 to both sides. We're actually going to add a 70 on both sides for completing the square. That's going to give us 8x squared plus 6x equals positive 65. Then after isolating the variable terms, we're going to divide by our a value. We're going to divide everything by 8. That's going to give us x squared plus 6 over 8, which reduces to 3 over 4. At this point, we can complete the square. So we need to figure out what we need to add to each side so that we can rewrite the left as a square. So I'm going to use our c equals b over 2 squared formula. But in this case, b is 3 over 4. 3 over 4 divided by 2 is the same as 3 over 4 times 1/2. And that is 3 over 8 squared. So we're going to go ahead and add 3 over 8 squared on both sides. And on the left, we're going to be able to rewrite it as a perfect square as x plus 3 over 8 squared. And then on the right side, let's simplify this. 3 squared is 9, 8 squared is 64. We need a common denominator on this side. We have 8 here and we have 64. So I need to change that 8 to a 64. I'm going to multiply the top and bottom by 8 so that I have 64 here. And then 65 times 8 will give us 520. And then we can go ahead and add that together. So that's 529 over 64. And on the left, we haven't done anything, so we're going to leave it or rewrite it. Now that we have the left side rewritten as a square and the right side simplified, we can go ahead and square root both sides. X plus 3 over 8 is equal to plus or minus. We can square root 529, and we can also square root 64. The square root of 529 is 23. The square root of 84 is 8. All right, so at this point, there's only one more thing we need to do to isolate our x value. We are going to subtract 3 over 8 on both sides. So while we do that, let's also go ahead and break it up into the two values because we have positive 23 over 8 minus 3 over 8, which will give us 20 over 8, which will also simplify to 5 over 2, which is one of the values we got earlier. But we also have x equals negative 23 over 8 minus 3 over 8, which is negative 26 over 8, simplifying to negative 13 over 4. So we just solved the same equation using 3 different methods and got the same answer each time. By factoring, we got 5 over 2 and negative 13 over 4. By using quadratic formula, 5 over 2 and negative 13 over 4. And by completing our square, we got 5 over 2 and negative 13 over 4.